Okay, this video we're going to learn how to solve compound interest application problems. So we're just using all the same formulas that we've been using before. We're just going to have more word problem kind of format for them. Okay, so our first one is we deposit $4,000 in an account that pays 8% interest compounded semi-annually, right? So as I'm reading this, I'm like, oh, I put $4,000 in, so that's my P. And my 8%, I'm going to change that to 0.08. That'll be my R. Compounded semi-annually. That means N is 2. Okay, and it says after 5 years, the interest rate is increased to 8.28%. So that must mean that it spent 5 years at this 8%, okay? And then it says the interest rate was increased to 8.28% compounded quarterly. So I now have a new R and a new N, okay? And it wants to know the total value of the account after a total of 10 years. Well, if I spent 5 years at the 8%, then I have 5 years left to spend at that 8.28%. So what this is sounding like I'm going to do is solve this problem twice, and the answer I get to my first time is the new P. So I'll show you what I'm talking about now. Okay, so I'm going to use the compound interest formula, the future value. Okay, so I'm trying to find A. P is 4,000 times 1 plus R is 0.08 and N is 2 to the 2 times 5 power for 5 years. And when I do this in my calculator, I get 5,920.97714. Okay, and I can just round that to $5,921 to round to the nearest whole dollar. Okay, and now I take this value. This is only what I have after 5 years. Okay, but now we're getting to the part where it says the interest rate is increased. So my account has $5,921 in it. Okay, so I restart the problem with $5,921, but now I have 8.28% interest, so that becomes 0.0828, compounded quarterly, so my N becomes a 4, N is still 4, and we're doing this for a total of 10 years. But we already used up 5 of those years, so it's just 5 more years. And I type that whole thing in my calculator, and I get $8,919.846, rounding to the nearest whole dollar. I just look at this 8, and that says this has to round up. So 1 up from 8,919 is $8,920. Okay, so this is my final answer. Okay, so now you try your problem where you start with $3,000 at 7% compounded semi-annually for 2 years, and then it increases to 7.24% compounded quarterly, and it's a total of 4 years, which is just 2 more years than the 2 you had here. Okay, and the answer and work will be up in 5, 4, 3, 2, 1. Okay, and you should have gotten a total of $3,974 after 4 years. Okay, next we have Dave, who won a photography contest, and he received $1,300 in cash, and he's thinking about how to invest it. Okay, so in 1 year, if he invests his winning in a simple interest account that pays 6%, how much would he make? And if he invests it in an account that pays 5.75% compounded monthly, how much will he earn? Okay, so first we have to realize we're going to use 2 different formulas. First, we have to do simple interest. So the future value of a simple interest is that A equals P times 1 plus RT. So in this case, P is that $1,300, and his R is 0.06, and T, if it's just 1 year, it's just 1. Okay, and if I type that in my calculator, 1,300 times 1 plus 0.06, I get $1,378. And now I have to do the investment at 5.75%, but that's compounded monthly. So that means I have to use the future value for compound interest instead. So that's the one that has the ends in it. So again, we start with $1,300, and the R is 0.0575, compounded monthly. So then to the 12 times 1 power for 1 year, and we get that A equals $1,376.75. Okay, and then what you have to do in this problem, actually, you have to choose A or B, and you have to say which one you make more money on. So which is bigger, $1,378 or $1,376.75. And it's the 1,378, which was simple interest. So Dave makes more in the simple interest. Okay, so you have to choose the box or the button that says simple interest makes more. Okay, and you have to say by how much money. So we just take that 1378 minus the 1376.75, which is $1.25 different. Since we're rounding to the nearest dollar, that's basically by $1. So you only choose A or B. Choose the one that says that simple interest is bigger. Okay, and the number in the box is just the $1. Okay, and now we're going to do this for Dave, who won a photography contest again, but this time he started with $1,400, and our accounts are paying either 4% or 3.75%. And which one will he earn more? The answer will be up in 5, 4, 3, 2, 1. Okay, so simple interest again is more money. It's more money by about $3 this time, remembering to round to the nearest dollar. Okay. Next one. Okay, so parents are trying to save some money for their child's education. Okay, they want to have $110,000. Okay, and right now they have a 6-year-old. And they can get 5% compounded semi-annually, and they want that money when their kid is 18. Okay, so this, because we're trying to figure out how much they have to put in now to get to their goal in the future, we have to use the present value formula, okay, because we want to know how much to put in right now. And that's the one that says P equals A over 1 plus R. Ooh, let's write the R up here. R over N to the NT power. Okay, so in this case, we want to know how much to put in now, the principal. Okay, we have $110,000 over 1 plus interest rate becomes 0.05 over N compounded semi-annually, so N is 2, to the 2 times T power. Okay, so how much time is it? Sometimes we're tempted to either just like pull one of the numbers from the problem, like 6 or 18, but really we're trying to figure out how much time do we have to get this money saved up. And we have until the kid is 18, but they're currently 6. So those are 12 years apart. So that's a 12. Okay, and then we just type that all in our calculator and get $60,816 and like 0.28896. That's what my calculator said. Okay, because this is a present value problem, okay, every time I use this formula, I need to round up. Okay, so our normal rounding technique, right, this is round to the nearest dollar. I would normally just look at this 2 and it would tell me whether I should keep that 6 the same or whether it should go up. But when it says round up, I always round up, even if it's lower than a 2. So it's $60,817. Because if I would round down to $60,816 over those 12 years, I wouldn't end up at that $110. I would be short of that amount of money. Okay, so you try this and try to make sure you get the rounding right for the parents who want $120,000 for at 4% compounded semi-annually for their 5-year-old when that kid turns 18. Okay. Answer up in 5, 4, 3, 2, 1. Okay, so the parents need to save up $71,710 right now so that they can have $120,000 in 13 years. Last problem for today. We have an account that has a nominal rate of 5.2%, and they want us to find the effective annual yield, rounded to the nearest hundredth of a percent, with quarterly compounding, monthly compounding, daily compounding. Okay, so this is just using the effective annual yield formula, okay, which is 1 plus the interest rate divided by the compounding, and then raised to the compounding power, and then minus 1, and then at the end, we have to multiply by 100. Okay, I've seen some of people write, like later we do that, or if you want to do it all in your calculator all at one time, you can put all of that in parentheses. Okay, but basically we're going to go through and do this problem 3 times. We're going to do it once with quarterly compounding. Okay, so with quarterly compounding, we have 1 plus 0.052 over 4 to the 4th power minus 1, and then we take our answer times 100, and we get 5.302, so that just rounds to 5.30%. And then we do the problem again, compounding monthly. Okay, so that's 1 plus 0.052 over 12 to the 12th power minus 1. And take your answer times 100. And that one works out to be 5.325, so 5.33 if we're rounding it. And then we have to do daily compounding with 360 days in a year. So 1 plus 0.052 over 360 to the 360th power minus 1. Take the whole thing times 100. Okay, and this one I get 5.337, so 5.34%. Okay, now you have to choose 2 of those 4 boxes for the multiple choice. Okay, and you have to find which ones are correct. There's 2 different kinds of statements. Okay, one of them is talking about the number of compoundings per year. Okay, so my number of compoundings is that n value. So in one of them we have 4 and then 12 and then 360. Okay, so as the number of compoundings increase, okay, or get larger or go up, right? As the compoundings increase from 4 to 12 to 360, what is happening to our effective annual yield? Okay, effective annual yield is increasing, right? So find the one that says as one thing, as the number of compoundings is getting bigger, so is effective annual yield. Okay? The other one is talking about the length of the compounding period. Okay? So as the length of the compounding period okay, what's happening to the length of our compounding period? If we have 4 compounding periods in a year, that means that each is about 90 days. Okay, that's the length of the compounding period, is about 90 days. When n is 12, okay, then my compounding period is only about 30 days. When n is 360, if I'm compounding daily, it's like how many days are in a day, right? It's just 1 day. So as my length of my compounding period goes from 90 to 30 to 1, that's decreasing, right? Decreases or gets smaller. We still want the effective annual yield is increasing, okay? Because as these numbers are getting smaller, these numbers are still getting bigger. So you're going to look for those 2 statements. All right, your assignment is to finish problems 11 through 14 and then any other problems that you have, and good luck.